So welcome to the review of organic chemistry. This is out of your review book, the 2020 review book. If it's after that, they're probably similar. These are the practice Regents questions at the end of topic 11. So let's get right to it. Number one says, in the alkane series, each molecule contains, well, the important word here is alkane. That's why I've highlighted it, alkane. So you know to look on table Q. And when you look at table Q, you recognize that the alkanes are the first column here. And so that tells you everything you need to know between the general formula, the name, and the structural formulas, and that should answer your question. Number two says, what kind of bond is most common in organic compounds? Organic compounds are between non-metals, and if it's non-metals, we're talking about covalent compounds. Number three, a carbon atom in an alkane has a total of, so for this one, you need to look at the carbon atom, and when you look at the carbon atom, its electron configuration is 2-4. So carbon is 2-4. It wants to achieve a stable octet, so in order to do that, it's going to need to bond in order to get this number to be 8. So what must you do? And you remember, you're doing two non-metals. Number four, it says the maximum number of covalent bonds that a carbon atom can form. Again, has to do with the number of valence electrons that carbon has. Carbon has 4, as indicated from your reference tables. So this last number here in the electron configuration number, 4. It has 4 valence electrons, and again, it wants to achieve a stable octet. 5 says a hydrocarbon molecule is saturated if, you need to understand what the definition of saturated is. And if you look on table Q, you'll see that the saturated are the alkanes. These are saturated. All right? The alkenes and the alkynes, they are unsaturated. Okay, those are unsaturated. What happened there? Number 6, which statement explains why the element carbon forms so many compounds? That is instrumental, having to do with the carbon atom. Carbon forms covalent bonds because it's a nonmetal, and it forms covalent bonds with itself. In the alkene series, which is the second one here, the alkenes, okay? It says each member differs from the preceding member by 1 carbon, which makes sense. That means the meth, eth, prop, bute, each one of those is different by 1. And it says the number of and 2 hydrogen atoms. Such a series of hydrocarbons is called, well, it has to do with what this thing is called, and the title of table Q tells you everything you need to know. Number 8 asks you to write structural formulas, and to do structural formulas, it's got to be unsaturated, and like I said, it's got to have the ratios of a alkene or an alkyne. The only one that would be saturated is an alkane. So now we just need to figure out which one is not an alkane. So you go through and figure out, okay, look at each one. And so you look at the first one. The first one has 3 carbons, and it has 8 hydrogens. 3 carbons, 8 hydrogen. That is an alkane. That is an alkane because it is C3H8. You look at number 2. It has 1, 2, 3, 4 carbons, and then it has 3, 6, 7, 8. All right, so it has 4 carbons, and it has 8 hydrogens. That is not an alkane. That is an alkene. We look at number 3. That is CH4. That is an alkane. The number of hydrogens is 1. 1 times 2 is 2 plus 2 is 4. That is CH4, that is an alkane. The fourth one, C2H3, C2H6. The number of hydrogens is twice the number of carbons plus 2, so that 2 is an alkane. The only one that is not an alkane is the number 2, which is an alkene, which is unsaturated. So if we're talking about condensation polymerization, condensation is your clue that we're dealing with water. This reaction here, you have to look at your structural formulas. You look at your functional groups of table R, and you are looking for this functional group where you have an oxygen that is between two carbons. Number 11, hydrocarbon contains a triple bond. This has to do with table Q. Organic acid, again, we're looking on table R. (13) again asks you to consider table R. Again, consider table R. (15) asks you to talk about a fermentation reaction. Part B1 has to do with determining the definition of an isomer. So you have your choice of either structural isomers, meaning positional, or functional group isomers. So when you look through these, they got to be the same compound, more or less, or same kind of idea. So for this question, it's going to take you a little bit to write out the formulas of all of these. So again, that takes some time to write them out, but once you do, you should be able to figure these out.